All right, here we are, Mr. Brennan, back with you. I hope you had fun with that assignment. It's fun to get back to geometry, so let's just get ready here. I'm gonna write my name, Mr. Brennan. 8.1 in page is 358 and 9. I usually don't do that, but I want to model. When you get to 7th grade, you have to do that. Upper right-hand corner, name, lesson pages. Please do that, please. Let's get started. We've been talking about two-dimensional geometry for a long time. And here we have three-dimensional geometry, but we're only talking about the faces, edges, and vertexes, and as well as some names, shapes. So we'll get right to that. Decide whether the statement is true or false. If false, explain your reasoning. Number 2, a triangular prism has 3 rectangular faces. That's interesting. Let's go ahead and find a picture of a triangular prism. One right here in number 19. Here's a pyramid, angular pyramid. Here's a triangular prism. So look here. Here's a rectangular face. Here's a rectangular face, and there's also one on the back. So that means the number 2 is true. Number 4, a rectangular pyramid has 3 triangular faces. Well, let's see if we can find a rectangular pyramid. Here's one here. You can see that right there. It's a square pyramid. Square is a type of rectangle. So the answer is no. 1, 2, 3, 4. There are 4. A rectangular pyramid has 4 triangular faces. False. It has 4 rectangular faces. Number 6. None of the edges of a rectangular are parallel. None of the edges of a rectangular pyramid are parallel. Well, let's come back here to our rectangular pyramid. None of these on the edges, but you can see the edge of the base. That's going to be parallel. So that's false also. The edges of the base are parallel. Okay, so let's come back to, I hope this makes C6 switching back and forth on these pages, but I want to show you what's going on. This one was kind of difficult because you can't really draw on your Google form. Number 8, draw the front side and top views of the stack number of the cubes, which was really easy. So the part you could do was find the number of cubes: 1, 2, 3, 4, 5, 6, 7, 8, 9. So your answer is 9 cubes. But since I can draw, let's do this. Let's draw the front. It's going to be 5 across. 1, 2, 3, 4, 5 across. And 3 on top of that. And then 1 up top. That's front. The side is just going to look like this, and it's going to look like 3. And the top is going to look like 5. 1, 2, 3, 5. So it's like that. Yeah, I wish you could draw these. It's the fun part. Sorry. Maybe you can do it for your own self. Number 10. Find the number of faces, edges, and vertices of a solid. So faces, what do you think this is, by the way? It looks like a 1, 2, 3, 5. So there's 5 on the bases. So that means this is a pentagon. It's a pentagonal prism. How about that? So it's not a pyramid because they never meet. So how many faces? 5, I said, plus the bottom and the top. So 7. There's 7 faces, edges. There's 1, 2, 3, 4, 5 on the top, 1, 2, 3, 4, 5 on the bottom. So that makes 10 plus these lines here, these edges here. So that makes 15. 5 plus 5 plus 5 is 15. And then the vertices are how many? 1, 2, 3, 4, 5 up top. 1, 2, 3, 4, 5 at bottom. So that makes 10 vertexes or vertices. Fun, eh? 12 is an interesting one. You think that's a prism or you think it's a pyramid? I was looking here and you can kind of tell that even from the start, you're going to meet right at that point there. It's not just that it's so 3 and it's so long. They are going to meet at a point there. So that makes this a pyramid. What kind of pyramid? 1, 2, 3, 4, 5, 6. So it's a hexagonal pyramid. So, but that's not what it was asking. It's asking how many faces does it have? So faces, 1, 2, 3, 4, 5, 6 up there, plus that makes 7. Hey, type the other one. Edges, 1, 2, 3, 4, 5, 6, plus 1, 2, 3, 4, 5, 6 equals 12. And then the vertices equals 1, 2, 3, 4, 5, 6. But then don't forget that one at the top, 7. Those are kind of fun. A lot of counting. Huh? And this one, I forget what I had you do. Number 14. I forget what I had you do. I don't remember, but I'm going to draw it. It says draw it pentagonal prism. So this is a pentagonal prism. So it's the pentagon. So I'm going to try to draw a pentagon. And we know that it doesn't have to be a regular pentagon. And I'm going to draw another one just like it underneath. Start with my point. This one comes in. This one comes here. This one comes here. And then I got invisible one in the background. So like over here, I had the invisible one in the background. So I think I just had this the same thing, but we'll figure that out. 16. The more you play with this, like I put that game, the net game on there for you. The more you play with these, the better you'll be. A hexagonal pyramid. Well, how interesting that it's the same thing. So I'm going to draw it the same way because I'm not such a great artist. Drawing this hex 6 sides, and then I'm going to here. These are the easy ones. And then these ones are the invisible ones. All right. 18, draw the front, side, top views of the solid. I should look and see what I had you do for last week when I put before I made this. I'm going to check. Hang on. I'm just laughing at myself because I told you to hang on, and it only takes 1 second if I turn it off and turn it on again. Yeah, so on these ones here, I just had you find the problem that had one. So we sort of did that anyway. Pentagonal prism. Here's a pentagonal prism. A hexagonal pyramid. Here's a hexagonal pyramid. So for 14 and 16, I would write 10 and write 12. Now for these kind, draw the front side. The top views you can't draw. So I had you name that shape, which is a risk for you anyway. Something you need to be good. So this is a pyramid. What kind of pyramid? It's got a triangle at the base. So it is a triangular pyramid. Pyramid. I don't know why I capitalized that. It shouldn't be capitalized. Number 20. What kind of shape is that? Looking at the couple people who've already done that assignment, they put it's a stair step, which really we know what's happening at the base. Since these are just shapes here, I'm going to count that side as the base. How many sides does it have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So a 6-sided figure, it's an irregular hexagon. So this is a hexagonal or a hexagonal prism. That's the best answer. Hexagonal prism. And if you want to make sure people won't confuse that, you might say it's irregular. I wrote the word irregular over there. So that's such a big deal. 22. And what is this? I've got regular basis here. This is a trapezoidal prism. Prism. 24. All right, let me move the camera off just a second. people wrote the weirdest things for this. Use the internet to find a picture of the Washington Monument. Describe its shape. So the Washington Monument, here's the top of it. It has a pyramid on top. You've seen pictures of it. This describe its shape. You could say that it is partly, it's well, it does taper a little bit, and then it has a pyramid on top. So I would say it's a prism, a square prism, or rectangular prism with pyramid on top. It's an obelisk. So an obelisk is actually the name of the shape too, but not in our vocabulary. Number 26. Draw a solid with the following front side of the top view. Number 26, one of my two favorite problems on this set, because you've got to draw. And what did I tell you to do? I told you, oh, I was kind of hoping that you would draw it. That's the part we're missing. If we were in school, we'd be drawing these things like crazy, especially like the next one, number 28, would be awesome. Even though we did last year Math Corner, it's exactly like this. So I'm going to draw number 26. You see what it looks like from the front, from the side. Oh, this could be a big block until we see the side view, and from the top. So I'm going to use, if you started, I know a lot of kids are just skipping around, but if you want to spend some time, uh, especially if you have access to isometric dot paper, you can just find that on the internet and print it out your own self. Or a lot of you are using graph paper, so that's the best thing. But I'm going to do a little bit of a isometric cheat here for number 26. I'm going to start with the front view, seeing what I see. So I'm only going to see these two on the bottom. I'm going to use the lines that I've got right here, my paper. I'm going to start down here, and I'm going to, you see, I'm going to make up a lot of room. I'm going to make these faces individual squares. And then I'm going to make these plate here come back exactly 1/2. See how I'm doing that? Exactly 1/2, and I'm going to try to chop that right in the middle. And you see if it was only 2 cubes, that it would look like that. Okay? Well, I've got a place to start. So here's the first 2 cubes. Now I know I can see the front here because I've turned it at an angle. And here's going to be my second row to here. Second row to there. And this would be the side of the view, right? It's going to go all the way back because there's going to be 3 layers. But every time this is one full thing, one full line set. So these lines here are going to come to the middle. Boy, I didn't do a good job of that. I'm going to cheat a little bit. And we see that's going to come up here. So that would be the first set. The second row there. Second layer. And then I've got one more. So I'm just going to bring this back here. And I probably wouldn't draw it exactly this way, except for I'm trying to demonstrate. I would have cheated. I would have made this all probably would have wound up being a little more even. And then this guy's got to go all the way up. Thought I saved myself enough room, but I didn't. These ones are straight up and down. Let's pretend those are perfect squares. And this is going to go in my last answer halfway. There, 1, 2, 3. So that's what number 26 looks like. Number 20, well, it's pretty ugly, but there it is. Number 28. So you could practice that. You should spend a lot of time with that. It's fun, and it's a skill you're going to need later. And there's all kinds of even career aspirations that you could do. Number 28. Took me a while to figure this problem out. It's a good one. 2 of the 3 views of a solid are shown. I've got the top and I've got the side, but I don't know what the front like. So, and I don't have any little blocks here to show you, but we'll find some here. What is the greatest number of cubes that could be in this solid? Well, I have the top and I have the side, but for A, and I'm just going to tell you, I would love to have you reason. I think there's about 10 or 15 different ones that could come from this. I haven't played with it, but I would love to play with this with you. It could look like this. Trying to figure out the most. If that's what the front looked like, then you could see the side would still only be one. And the top would only be one row of three. So that A equals 9. There could be 9 cubes. That would be the most. B, though, if I were trying to look and see what is the least number, it could be, well, it's got to be tall. So it could be shaped like this, some way like that. The least number is going to be 3 again, but it could only be 3 this way too. So 1, 2, 3, 4, 5. So it could be 5. That would be the least number it could be. Draw the front view of both solids in part A and B. I did. So C is, look at that, but you can't really do that. So sorry about that. The last part here is just stuff that we have done a great deal of. I'm going to use the same paper. I hope that's okay. Number 30. How do I figure out, what is this? It's a parallelogram. Oh yeah, parallelogram is just base times height. So I know that the answer is going to be times 8. It's 28 square meters squared. And the last one, this is a trapezoid. It's not a parallelogram. It's a trapezoid. So did you remember? Do you remember the formula? So it's going to be 1/2 base plus height. So, oh, I'm sorry, B1 plus B2. What did I say? Wow, times this. So the bases are 10. 10 is 30. It's going to equal 15. I wasn't clear on that, was I? 10 or 6 plus 4 is 10. 10 times 3 is 30. And then take 1/2 of that. It's going to be 15 square feet. Well, I hope you had fun with this. I want to keep this video under 20 minutes. So I will see you next time. Bye-bye.